Here I'm showing you a photo from the outside space where we are actually seeing Earth. We've gone outside our Earth's atmosphere and standing by the side of some satellite, let us say International Space Station or something. Let us say you are standing there and you actually keep, let us say, one big stone or a rock. What you will be surprised is that we don't realize that the so-called gravitational force is always there everywhere. Let's say they are separated by a distance of 10 meters. Okay. And if you just keep them like that sometime, what will happen? So they don't actually stand like that. So they experience a certain force. Okay, that force is called gravitational force, which make it come together and stick to each other. We always think gravitation as something which happens on the earth. No. It's a universal law of gravitation. Any two things, if you keep in the space, gradually they come near. So that force, gravitational force, is very much dependent on the distance between them. If the distance between them is small, okay, then the force is higher. If the distance between them is large, the force is very much smaller. But however, now this force is very weak. So this is a very weak attractive force, and we call it as gravitational force. And it is never repulsive. It is always attractive. It never repels. Okay, whereas in magnets we have seen that two magnets can repel. But it is quite weak, very weak force. And even to look at the effect of the gravitation, such a weak gravitational force, now it has lots of effects. The rain droplets coming down is because of the gravitation. And at the same time, the same gravitation is responsible for moon going around the earth and earth going around the sun. And it is the same gravitation which is responsible for our sun going around in the Milky Way galaxy. And even to the extent of so-called black holes, a small, very dense material which can't be seen, which even attracts light. Those black holes are also formed because of the gravitational pull. So now the gravitational force, you see, has some characteristics. It is a universal force. It is there everywhere. This gravitational force is present everywhere. It's universal. And it's always attractive. There is no repulsion. And it is a weak force. These are the three characters of a gravitational force. Now, if you take, for example, a similar force, assume that I have another universal force, like gravity, okay, which is always attractive, but is a billion times stronger than gravity. Okay, assume that it is very strong. A billion times is very strong. A billion times is even more strong. If such a force is available, apart from gravity, or if gravity itself is that powerful, what would have happened to our universe? Think about it. Our universe would have actually got the whole universe attracting everything else is so powerfully. All planets coming together, all galaxies coming together, everything coming together, pulled into a tight ball. Just one tight ball called the universe would have been there. If we had an attractive force universally, which is billion times stronger, our universe wouldn't have existed like this. It would have been a small ball, whole of the material of the universe inside one small ball, because they all attract so powerful. So it's a very difficult thought, isn't it? So what if, suppose, our universe is actually having a force which is always repulsive. Instead of attractive, it is very repulsive. But it is billion times stronger than gravity. So we know that gravity is actually attractive. But if you take a repulsive force, which is a billion times stronger than gravity, but it is repulsive, how would our universe be if such is the case? So our own universe would have been a simply ever expanding gaseous cloud with every bit of matter repelling every other bit. The planets would not have got formed, we would not have got formed, nothing would have happened. It would have been all bits going away from everybody else because it's all repelling. So that would have been the case of the universe if you had a repelling force which is much stronger than gravity. Now, why are we thinking like, suppose if the universe had both kinds of situations, it had both very strong repulsive force and very strong attractive force. Let's say the universe had two kinds of materials. I will call them as p particles and n particles. Okay, exactly equal in number. 50% of the particles are p particles and 50% of the particles are n particles. Let's say p and p particles always repel with enormous force, and n particles also repel with enormous force, like billion times stronger than gravity. And let's say P and N attract with enormous force. There's a lot of attraction in one side and a lot of repulsion on the other side. If both such scenarios existed, what would be the universe like? How would the universe be if such is the case? Interesting thought. So the answer actually is quite simple, surprising. The universe would be the one that we are living in. It would be exactly like the universe that we are living in. In our universe, there are such particles which are positively charged and n particles which are negatively charged. They actually repel and they are equal in number. They are exactly equal in number. There is such a force called electric force. It is actually such that positive particles and positive particles repel and positive negatives attract. So such particles have formed our universe. They come together as electrons, protons and all. They are equal in number. Okay, they form actually atoms. The atoms form molecules. Molecules form the matter. It plants the planets, stars, and galaxies. Everything happens, and our lively universe is born because of such an electric force that is so delicately balanced that there is always, in a small speck of matter if you take, there is equal number of positive and negative charges. Hence, they don't repel away or attract away. So they create a certain material. Okay? And such a force is what we want to study. We want to study our universe by understanding this kind of a beautiful electrical force, very powerful electric force. When compared to gravitational force, it is damn powerful. So we're going to study that through our videos of electricity.